Okay, I think we have reached the 5-minute contemporary time. So this is the Thing2Thing research group. I'm Carsten Bormann. Ari Karanen is the chair who actually does the work. I'm just, my name is just on the group. This is an IPR meeting. So the IPR guidelines of the IETF apply. And there are some more detailed Node well slides that I assume you have seen. So we have IPR disclosure rules that apply if you are talking about some technology and know that there are some patent claims to it, then you have to tell, or you can choose just to not to talk about the technology. We try to be nice and try to be professional. Yeah, maybe it bears repeating that this is an IETF meeting, so we are not forging standards here. We are trying to talk about research that may be useful for forging standards or for other purposes. We are also not an organization that has liaisons in any formal sense, but of course doing research means that you talk to a lot of people. So do we have, the blue sheet is in the CodeMD notes, which maybe you can send around to the chat once more for people who came late. Thank you. Do we have note takers? So I think Ari is going to take some notes in the CodeMD. Does anybody else want to help?
So everyone is free to participate in the note taking. This CodeMD is open for anyone to update. So feel free to jump in whenever you feel like it.
Yes, and don't just feel free, but actually do. This is an IETF CodeMD, so if you want to log in, you can do this using data tracker, but I think the document is free for all to edit, right? I'm not seeing that at the moment.
Yes, it's really freely editable.
Okay, thank you. So we actually have a Jabber room. I don't know if anybody is in there right now. We have a mailing list, and we have a repository which contains the slides and will contain any other documents that we want to make available in the context of this meeting. And of course, it contains the agenda. The agenda is, of course, also in the usual place in the data tracker. So our agenda is pretty full, and I have already used the first 10 minutes, so I have to really hurry up here because we are already running late. We have a couple of talks. One is at the beginning and one is at the end for various reasons. And the middle of this sandwich is going to be a segment about industry updates, and I'll lead into that in a couple of minutes. Yeah, so we are interested in doing research that is needed to make a true Internet of Things reality, and we do this cross stack. So we're not exactly starting at the antenna. We are starting approximately where the IETF starts, at the IP adaptation layer, and we end with users and security and architectures and data. And so if you want to visualize that, the research group does some things, the IETF does some things, and we do have overlap occasionally, and I think we have been reasonably successful in managing that overlap. So let me quickly mention how things are going to go on after this meeting. The most regular thing that currently happens in the research group are the Wishy calls, which are happening approximately monthly, maybe with a pause in August. And the next one is going to be on the 30th. During the IETF, unfortunately, that was something we couldn't avoid. But after the last session of the IETF. So unless you're in China and it's already past midnight, you might be able to join. So we plan to also have other meetings with other organizations, some more topic-based meetings maybe. We probably will have another summary meeting at or around IETF 109, and we will learn in August whether that's a physical meeting or another online meeting. And yeah, the whole idea of co-locating with academic conferences really is taking a break right now, but of course at some point we will be able to do that again. And maybe we also will find an online form of co-locating that we still have to invent. Okay, we have two documents that are research group documents are trying to become one. We're not going to talk about RESTful design today. We will talk about IoT Edge at the end of the meeting. This is in research group adoption call. So if you have an opinion on this, please send a message to the mailing list. And also we are ramping up something called Wishy notes, and right now this probably will start with some terminology, but might grow to include other things. Okay, Ari, do you want to report about Wishy?
Sure, thanks, Carsten. So as many of you know, I mean, Wishy is this long-running activity in the Think2Think research group where we've been focusing on semantics and hypermedia interoperability. And since the last summer meeting, we have had now 4 online meetings with a variety of topics. For example, there is this now new survey of semantics technology landscape that is driven by Milan Milenkovic and Michael Koster. This work has 2 main parts. It first of all proposes a unified criteria for describing IoT data standards, but also provides a meta-model survey of 14 different SDOs, comparing both organizational and technical aspects of those models. Also, we have had Jonathan Berry to lead the discussion on interworking of OpenAPI, async API description methods, and the IETF core technologies. And there we have been discussing a proposed way to extend the OpenAPI specs to support co-op features. We have been for a year already collaborating closely with the One Data Model Liaison Group, and we've been exploring various research and standardization topics relevant for that work. And 1DM has also been a topic of multiple hackathons, and we've explored various architectural, semantic interoperability topics in that scope. But most recently, we have been focusing on this potential standardization of the SDF language, and naturally, we have discussed the upcoming ASDF of quite a bit that Carsten will be discussing more a bit later. We also have continued our close collaboration with the W3C Web of Things, and in particular, we have explored the topic of how 1DM SDF and the Web of Things thing description and thing description templates can work together. On Web of Things specific topics, we have been discussing enabling efficient discovery. And this discovery also relates to the last topic of this identifiers, reference paths, and pointers, how we can express all of these in efficient but versatile ways to enable discovery and other uses. And also one proposal coming out of this work has been this potential for JSON patch standardization. It's going to be discussed at the IETF 108 dispatch meeting. For Wishy, on the next slide, we have a quick update on the Helsinki meeting. So we're planning to have a face-to-face meeting in Helsinki together with the W3C Web of Things. But due to Corona, this was also transformed in a half-day online meeting, but we still have been calling it in the Helsinki meeting. So in this meeting, we did discuss the Web of Things use case collection effort. There's an effort with about 20 IoT use cases in the pipeline already. And Web of Things folks, they welcome everyone to contribute to this work and also use this information. Also, discuss lifecycle and discovery. Those are topics that we have lots of common interest with Web of Things. Also, discuss the Web of Things market and retail proof of concept activities. And we continue also in this meeting the discussions about 1DM SDF and how Web of Things theme description could integrate and interwork together. In this meeting, we also briefly discuss the use and design alternatives of hypermedia controls in theme descriptions.
Ari, there are minutes taken for the workshop. Can we maybe put a link to those minutes into these minutes so people can easily find them?
Absolutely.
I think that also then links to the archived presentations and so forth.
That's a good idea.
I should say some of these are definitely ongoing. We have a very active discussion going on right now about hypermedia controls, for example. That if you're interested in that topic, it relates also to dynamic TDs versus static TDs.
Okay, so we will hear some more about what
Yes.
Okay, so the next, after the introduction and the reports, the next talk will be some work on bringing Web of Things TSN and OPC UA together. Matthias, do you want to start to talk?
Yeah, sure. Thanks, Karsten. So yeah, this is a follow-up of a work that I presented in Singapore when the world was normal. And it's in this category of semantics-driven connectivity. And we now filled out some details and basically wrote it up together in a paper that's going to appear in the IoT conference in September this year. And it's about bringing deterministic industrial networking to the W3C Web of Things using TSN and OPC UA. Next slide, please. So for the background, industrial IoT usually requires something like deterministic networking or some special properties that can be controlled through the whole stack. And the main part here is that the applications get some QoS guarantees from the whole protocol stack. And that mainly led to this plethora of field buses that you can find in industrial environments. Noteworthy there, it's like 94% wired. Wireless has a small part here. Luckily, it's going from just wires to something that is Ethernet based, but it's still all different and not really compatible. Some good thing at the horizon is time-sensitive networking, which is being standardized for now quite some time in the IEEE. So it's based on standard Ethernet. It reuses the VLAN headers to encode some more information, and this way enables basically a converged network that can also give these tight quality of service guarantees to applications, but can coexist with normal IT traffic. One thing to consider here is it's not just plugging in your cable. It requires very detailed network configuration as well. Next slide, please. And for this, there are different models. So you can do this centralized, distributed, or in some kind of hybrid way. For now, the centralized model is kind of the predominant way, usually because historically these deployments in industry applications are planned and then actually also monitored and so on from a central place. On the left-hand side, you can see how this works. So there are entities involved that are called like a centralized user configuration. That is something that can talk to the applications and understands the application protocols. That then needs some uniform interface to the so-called centralized network configuration. that is then something that can talk to the bridges, so manage switches and so on in the network, and basically does the resource allocation so that these guarantees that were requested by the users can be met. And so in this world, one mainly uses Yang. That's something that many of you might know from this CoreConf activity and the LP1 work, often reported also here in the T2TRG. In principle, there would be multiple choices, like the historic netconf, RESTconf, which is HTTP based and would fit nicely in the web world. Also CoreConf. The thing is that most network equipment out there is still using netconf. So RESTconf is something that at least I mainly see in SDN controllers that work with a lot of virtual machines and virtual switches. But if you go to the physical world, you have to deal with netconf and according Yang modules. So this is one thing we have to address. And then next slide, please. Then the other part to address is how it looks at the application layer. So industry, as usual, is quite shielded. One interesting technology here is OPC-UA, which is luckily a cross-vendor application. So it's supported by a large number of players in the industrial space. Overall, it has an interesting graph-based information model. So that's one of the main contributions here, to agree on semantics as well. And it defines its own communication protocols under this, however. It's mainly used as special binary format that can be used either as a client server, and now slowly coming up in products is a PubSub version of this that can have different bindings for cloud connectivity, for instance, MQTT, AMQP, but to use it locally, it also works over UDP or directly over layer 2. So the most OPC-UA applications at the moment, they take care of management and monitoring of such applications. However, on the right-hand side, what is currently ongoing work is the so-called field level communications for OPC-UA, which then extends this ecosystem to actually be able to also cover the controllers and end devices in the field. And to enable real-time applications, it integrates this time-sensitive networking that I just mentioned, and tries to provide a full stack for this. Next slide, please. So to give you a rough idea, on the left-hand side, you see a screenshot from one of the tools. It uses this graph-based model that I mentioned. In this tool, you can actually also browse through the data that is available on controllers, for instance. And it then has so-called nodes that are quite similar to resources, which is a good starting point if you want to include this in the Web of Things environment. So you can see on the left-hand side under value, there's this ns equals 2, which is a namespace. So actually they use URIs, but they convert it to integers, and then follows a node identifier, in this case a string, this hello world. And with this you can identify a node or a resource. And a different is that they are strict node classes. So unlike resources, which could be anything, there are only certain classes of resources possible with OPC-UA. And there are some more things that make it a bit less compatible with the web. For instance, the references in OPC-UA are bidirectional. There's support for bitmap data types. They define word sizes, so you have to know if it's a 16-bit integer or a 32-bit integer, unsigned, and so on. So things that were actually already solved in the web, but still used in these kind of partially low-level applications. Good. Next slide, please. The last ingredient is the Web of Things. I don't think I have to tell this group anything more about this. So it's using this overall ecosystem that mainly focuses it integrating different application domains. So for instance, industrial automation with the building automation or energy management. And this is why we want to bring the time-sensitive networking and OPC UA also in this scope. Next slide, please. Good. So what do we really want to achieve? I just summarized, and how should it look like? Next slide, please. So on the left-hand side, you see what we call a servient, which is like the Web of Things software stack that is able to run applications that are written against the scripting API, and what runtime then handles these abstractions and is able to communicate with so-called protocol bindings, here colored in green. And here, basically what we did is we provided two bindings, one for OPC UA, for the operational part, and netconf for the network configuration. And the overall flow works like this. So on the right-hand side, I think I can't use my mouse or anything. You see the devices. They would all get a thing description, but we also provide a quality of service vocabulary. So those can be annotated with the capabilities what these devices can provide. So how fast they could send data, how quickly they could receive data, and some other properties. And this then has to be combined with the QoS requirements on the left-hand side of, for instance, a controller application. So only this application actually knows what cycle times, so meaning how often does a control loop have to be triggered, how often sensor data has to arrive. This is defined by the application, and it must match that to the capabilities of these things. And with this, it can then basically request network configuration that would suit this controller application that has to talk to certain devices. The concept here is that the controller app can talk through Web of Things interfaces, so basically by consuming a virtual thing here. The TSN scheduler app, which can also run on a servient. That scheduler app then basically calculates from the requirements, so which communication is required, network configuration, then pushes this out through the netconf binding, so basically talks to these switches. Sometimes it's actually also end devices that support this protocol and are configured this way. And if this is successful, it will respond positively to the controller app, which then can start operation through OPC UA. Good. And in the next slides, I will present the building blocks that we provided. So one I mentioned is this vocabulary for quality of service. This is a summary table. I think it goes a bit into too much detail if I now explain all these vocabularies. This is something that I would love to follow up with some experts on the one hand side in the semantic modeling area. On the other hand, also with people who do quality of service for other projects or technologies. So not only TSN, but there could be other mechanisms. And if these actually apply also to these other technologies. Good. Next slide, please. The other concept is basically that you also have to annotate things with capability terms. So for, as I already mentioned, like min cycle, how fast can it process data? What is the minimum cycle? The maximum cycle to receive that? Another aspect is, for instance, a working clock. If devices can actually synchronize to a clock, there's this precision time protocol, for instance, or some profiles. And we also need to learn within the forms how big are actually the messages in bytes so that we can calculate schedules. And next slide, please. This is kind of a summary where this vocabulary applies. So starting from the left, you have to describe the application requirements. So this is actually some internal data that is included in the application code. So for traffic class, it knows what is the priority? Is it like isochronous real time? Is it only soft periodic, or is it best effort? It knows cycle times, meaning, for instance, with what frequency the control loop has to be run, and then some other more details, like if it's a isochronous or deadline traffic class, when is this deadline within the application cycle, and also what kind of loss is allowed. And it also, when it knows which devices to communicate with, it has to basically assign some unique names that can then be used by the scheduler app. So in the second row, that is basically vocabulary that is used to annotate a scheduler action. And this is then basically annotating the input data schema of this action. So this is based on the scheduler that we have, what information it needs, and basically filled out by the other three. So the controller app knows some of these parts. The thing knows some parts, as I mentioned, the capabilities. And lastly, the form also has to provide some more details, like the byte sizes that I mentioned. But we also need information like listener and talker, which is then MAC address actually that is required to do so. It can be a unicast interface address or a multicast MAC address, but it's also required for this layer 2 technology to provide the schedule. Good. Just a quick check. Audio is still working. Sometimes I had this that I'm talking, nobody's there. Okay. Okay. Well, it says 8 here, but then next slide, please. Yet again. So this is about the mappings that we did. So for OPC UA, I mentioned already, it's quite straightforward with these nodes mapping to resources. So we could easily fit into the property actions and events. Next key, please. For the data schema, here the issue was mainly the binary data types. So the JSON schema is not sufficient to describe to the binding, or actually the content service, how to encode and how to parse this information. So we had to add an additional annotation here. For the form URI that you need, I mean, it's a protocol, so it has to be identified with a URI scheme. Here, we propose to reuse the existing opc.tcp scheme, which unfortunately is not registered with IANA, but already used in deployments. But combine it with some information at the later part that gives the node IDs and so on to have a final addressing of which node you want to talk to. And we stuck to the notation with the semicolon that is already used in all the OPC UA tooling, instead of converting this to something HTTP local, because it's its own scheme, so it can define the mechanism behind it. And we stuck with what is already familiar to OPC people. Content type, you need some. There's nothing registered, so at the moment we are basically working with an experimental one, but it would basically describe this UA binary encoding, and can then call the right content service to parse this to the JSON used by what applications. Next slide, please. For the netconf binding, to make it quick, luckily there is RESTconf, which already defines a lot of things, and eased basically to have netconf be compatible with the RESTful approach we find in the Web of Things. Two takeaways maybe. So one, for the data schema, you encounter the issue with XML-based features. So if you have these XML node attributes that are not supported by JSON, we somehow need the mechanism to express them in the JSON schema-based data schema. And we did this through additional annotations that you basically use a complex structure and you say some of these fields are actually attributes for this object. And so the containing node and not child nodes or members in JSON terms. And for the URI, we could almost take it directly. However, there are still some more features in netconf, like the data store. So we have a proposal to include this in the URI scheme semantics, that basically the first path segment is the data store that is selected for the write or read what you want to perform. Content type, straightforward. We can use this XML type from RESTconf. That was nice. Next slide, please. These are some examples. They need details, so, and I don't have the time, so please have a look offline to this. And on the next slide, or slides, I want to conclude. I don't have nice pictures because our lab was in lockdown. However, on the next slide, I have a nice video that hopefully works. Frame rate is not well, but here you see our testbed that we built. So it uses real equipment like this Beckhoff XDS transport system and the Universal Robots robot. And it's basically these levers that you see. In the center top, you see a small bolt that is controlled that basically only flips the blue bonds. And then we can tell the robot to flip back up the blue bonds. And this is running through this TSN network. And it's controlled with a supervisory logic based on Node.js and the Node.watt project, and overall uses these thing descriptions and so on for the configuration. Good. Last slide.
Sorry, quick question. Are there AI components of this?
Sorry, Ian?
Are there any computer vision services or AI components of this implementation?
There is no UI for the supervisory logic. There are some other things that are included, but not, yeah, they are separate technology for different purposes, like a digital twin or something like this.
Okay. I guess we're looking at edge computing and AI offload in Web of Things, and some of that may be applicable to some of these use cases. But.
Exactly. So the supervisory logic is basically running on an edge node. So underneath there are these racks, and there's a server in there that is connected to the TSN network, and through that, yeah, can communicate then with the devices. We have open sourced the code for this, and the first version, or like the early prototype, is already merged. There's some polishing work that we did while writing the paper. This update is still pending, but hopefully, yeah, contributed soon. I guess the biggest caveat is that this TSN scheduler app is not included. That's because it's internal proprietary work. However, there's interestingly an open source scheduler, which could be a good starting point for some future work to make this kind of scenario yeah, more accessible for the research community and the bot community. And yeah, for details, stay tuned for the paper. Should be published in September. Thank you.
Okay, thank you, Matthias. I think we actually do have time for a question. So anybody else who has a question about this?
So I guess what's the roadmap for standardization here? Do you have expectation of proposing something within IETF or W3C, or what?
So there is this open GitHub issue where you ask what protocols, what protocol bindings to go next. We're actually planning to put a preprint on this archive website and submit it there, and then through this activity continue there.
Okay.
Currently, I'm not pushing this toward IEEE or these folks because they're more conservative and currently are fully busy with their own extensions.
Yeah. Okay. So we'll see. I guess the WAT protocol bindings is the next step then.
Exactly. So especially, I think there was some more interest in OPC UA. One limitation that I mentioned, or sorry, it's only on the slides. We started out with the client-server architecture at the moment because the Node OPC UA implementation that we use doesn't support PubSub yet. I'm working with a C implementation of this. So we have to see if we can get the PubSub working somehow in a what stack.
I think another orthogonal issue here is the data modeling problems that you ran into. It seems like, we should revisit and push harder on JSON schema and its improvements to deal with these issues officially, in an official way.
Yeah, if you have like a maintenance thread or something for the data schema, if you could point me to this, then I could at least like these issues with the XML binding, I think are very generic and would be good to solve.
Yeah, it's been on my to-do list forever, and we need to pull in Henry Andrews and have a conversation.
Yeah.
Okay, thank you, Matthias. That was very interesting. that was our first research segment. And now I would like to start the industry updates segment. And of course, the question is, this is a research group, so why do we have industry updates? And the observation, of course, is that in the IoT space, you can invent a lot of things, but if it doesn't make it into industry products and industry standards, it's going to be less useful. There are lots of SDOs out there that do interesting things, but their communication often is oriented at decision makers and cannot be understood by engineers. Hidden behind the press releases, there may be some interesting technical innovations, and we're trying to uncover them, and in particular uncover the research questions that really came up here. And I think we just did this in Matthias' presentation because what he did again has an impact on how we work with data models. So that's a typical thing that's happening. So we are planning to have short segments about industry updates in all future summary meetings. This time it's kind of trying to cover the whole space, which is why we have so many of those. Maybe next time it will be more focused on some specific items. So this is my intro to this. And the first industry update, we seem to have a shortage of Michaels today. Only have 2, we usually have 3. So Michael Richardson was supposed to present this. So maybe we can just go to the next Michael. Michael Costa, can you do the?
Sure, I'm here. Yeah, I'm ready. So, yeah, advance slide, please. Great. So, really, I have updates on a couple of activities. One that maybe not be so familiar with the details would be Project CHIP, Connected Home over IP in the Zigbee Alliance. And just to summarize that, I don't really have a lot of detail, but I can take a few questions. Basically, the players in smart home, the commercial players in smart home all got together and kind of took over the Zigbee Alliance, if you will, to create this Project CHIP specification. And the idea is to bring IP protocol networks to smart home. So it's focused on delivering smart home connectivity over Wi-Fi thread and IP over BLE systems, since a lot of these devices have BLE. We add that as a transport. So basically, though, this is basically the push for common IP connectivity in smart homes. I guess I probably should have thought about a little more technical detail, but it's not really, there isn't really a good architecture spec. It's really being done with a sort of a code first design document based approach. So there's an open source design. There's basically an open source repo that you can go to and look at and see everything that's been contributed by the different companies. little code has been contributed by Silicon Labs since the data model part, the part that we're interested in, is basically going to follow the Zigbee data model. So essentially, there are a couple of ways that Zigbee is opening up their data model. One is through this chip project and the open sourcing of the embedded stack that processes the data model elements in the meta model, and the data models themselves. The cluster library, as it's called, the Zigbee cluster library, is now published as open source using the BSD3 clause license. So all of the, it's an XML format right now, but there are basically, as you'll hear later, ways of translating that we're working on. So Project Chip is being contributed to by all of these companies, and many companies, actually many vendors. Too many to even list. There are about 200 companies signed up, 20 or 30 really strong contributors. We have a simple demo that just became operational, which is basically a little hello world, a little echo. I think you can turn a light on and off, basically, or a simulated light on and off with a light switch. So it's sort of a proximal network demo with switch connecting to a light. I didn't really get into it, but I said interoperability over IP networks. It sort of focuses on being able to have a smart home with proximal network and devices directly interacting with maybe hubs where applications, more complex applications run, but also the internet at large. It isn't really restricted to just the smart home, but it really is, and I didn't really make a big point of this, but the last bullet, it's about certifying devices. So it's not really about network standards the way we think about them in IETF. It's about being able to run a bunch of certification tests and qualify a device for conformance and for interoperability. So in addition to the historical Zigbee mission of device conformance and more of a business focused, this project Chip is definitely more customer focused and focused on delivering interoperable devices, so that the whole stack, it's a whole stack approach, but using pieces from wherever we can get them. We're currently debating incorporation of CBOR as the wire format for data as opposed to TLVs, and so we're doing a little bit of a trade-off around that question right now, for example. Right. So any questions, comments? Oh, okay, either it's not that interesting or I did a good job of summarizing. Let's go on to the one data model. Next slide, please. Right, so one data model also came out of Zigbee, strangely enough. In the fall of 2018, Zigbee brought together a bunch of other SDOs like OCF and OMA and folks from Bluetooth and one M2M as well. I think we need to re-engage with one M2M because the Huawei connection has sort of pulled them away from a lot of the work we're doing, but now we can get back in business with them. So one M2M and some of these other associations, they got together and sort of listed their top issues, and really lack of a common data model was really something that everyone said was holding things back. So one data model was sort of started as an industry liaison group, all these STOs and vendors and some invited experts to look at this problem. And originally, I think it was thought that Zigbee had a data model and OCF had a data model, meaning that there were already a bunch of definitions for things like thermostats and lights and switches and door locks, and that maybe people could just adopt one of those. But that didn't happen. There wasn't any one of these models that really anyone else wanted to adopt. They're all very, very close held to their organizations, and some of them are more general than others, but they didn't really have the use case coverage. So what the group decided to do was go off and create a common language and a common meta model first that can express all of these other IoT data models as a way of basically ultimately driving convergence from diverse models. So rather than just down selecting on one model that already existed and building on that, this became an effort of converging across industry, really, even including some of these energy and microgrid verticals like SunSpec that currently has a Modbus model, bunch of Modbus register definitions for solar inverters and stuff, but they want to use one data model as well. So we have a language, and basically it's based on defining common classes of affordance that allow you to build semantic type definitions on top of that. And it's aligned with the Web of Things model in this respect, the thing description model. It's aligned with the work we're doing in IoT schema. And it's also, earlier Karsten mentioned this sort of cross 14 different standards and how they all model things. And there's a sort of a common alignment that we're taking advantage there in one data model that use these common classes of affordances. So we're not really modeling internal behaviors and all of that. We're really starting to focus on these common classes of affordances. How do you turn the light on and off, and how do you dim it, and how do you find out what the temperature is, and what are all the semantic types of data? So it's about interoperability, but at a more abstract level. Next slide, please. Yeah. So where we are with that is our phase one is nominally complete. The language will, of course, always evolve, but we have a language that we think is stable enough to be able to create a bunch of models, and we've indeed done that. We have about 200 model definitions, mostly from OMA and OCF, but also a few examples from Zigbee and Bluetooth Mesh, and more examples coming along the way for things like field buses and the SunSpec stuff and BCUA, hopefully, and things like that. One of the things we did accomplish, and I said that originally these folks all got together under liaison agreement because they're used to working in a patent pool type arrangement where they kind of share intellectual property. But what we quickly realized is we didn't want to have these data models carry any intellectual property with them. They're just data models. So we basically got all of the organizations to agree to publish their data models, at least using the SDF format, the one data model language format, under the BSD 3 clause open source license. So phase two, pardon me, where we're looking at data model consolidation and organizations coming and publishing their models and getting the interaction going to sort of create some common basis for modeling. And again, this is diverse transfer layer protocols. So we're really working at the layer above transfer layers. We need protocol bindings, but that's out of scope. But we're working on consolidating just these models. So since everyone's agreed to publish under BSD 3 clause, we're going to open up the group to a broader participation based on an open source contribution model as opposed to a liaison model. We'll probably keep the liaison for a core group of people to be able to maybe do some long-term planning and governance and stuff, but we're not going to operate under any kind of a closed IP anymore. It's all going to be just BSD 3 clause. So we built public-facing website and content, and we're basically open for business, if you will. We want to. We don't really have all of our procedures and policies in place, but we do want to get people to start help us with the next development of the language, bring more use cases, bring more models. That's basically where we are right now. That's what I have for 1DM. Questions, comments? Oh, again, good. Thank you very much. Yep.
Michael, I had a question for the previous one, this project Home over IP. Yes. I wasn't sure if I missed like a preceding slide. Is there a proper name or some what's
Okay, so project, yeah, the proper name, that's an interesting question. We're calling it Project CHIP, CHIP, connecting home over IP, but that's just a working project name. There's going to be an actual trademark name for the protocol that's going to be the brand name. So CHIP isn't the brand name, it's just the working project name. But,
okay.
Huawei is now a member of Zigbee, and Huawei is now involved in Project CHIP, so your colleagues may be able to share more information.
Okay, so but there's no landing page yet or something like this?
Well, there's a little bit, but it's the open source repo. This is really an
Okay.
open source project, and if you really want to know how it's going, you can. The start here is pretty much the repository. I can send you some pointers as well.
Okay, thank you.
Yeah, thank you.
Thank you, Michael. And I think we will return to 1DM when I talk about the ASDF BOF, so maybe we can have more questions that come up there. So Project CHIP is certainly interesting, and we will need to track what's going on in there. So the next thing on the agenda is OMA SpecWorks. Travis, are you there?
I am. Can you guys hear me?
Yes.
Okay. Great. Yeah, I wanted just to give you guys an update on a couple of working groups we have in OMA. The Device Management Service Enablement Group, which is basically the lightweight M2M stuff, and then the IFSO IP Smart Objects update. So next slide. So we're about to release the version 1.2. We're just now finishing up some consistency reviews. So you should be seeing a release from us here shortly this summer. Just wanted to highlight some of the updates that we have in this new release. If you're familiar with lightweight M2M, it operates at the application layer of the stack. In previous versions, it was a CoAP UDP, had some LoRa involved in 1.1, but it was, pretty much had a prescriptive stack. What we're now allowing in 1.2 is becoming more transport agnostic with the messaging layer of MQTT and HTTP. There's different use cases that, some more cloud-friendly services that we've found that this enabled that capability. There's some optimizations in 1.2 of optimizing, how much data is put over the wire for bootstrapping and registration, reducing the amount of data needed, as well as in our information reporting interface. We've now optimized how that operation works. One feature we're really excited about is our lightweight and gateway capability. For those in the industry, there's a lot of brownfield devices out there that may or may not have a device, a consistent device management protocol. And so what the gateway allows us to do is start to manage multiple devices in those brownfield scenarios with a common protocol at the gateway level back to whatever your services side is. We're also going to be publishing a new encoding format that we call lightweight M2M CBORD. It will be published as part of the 1.2 release. You can see how the optimizations that we are doing for that one. Next slide.
Oops.
Okay, just some more updates here. We have new notification updates, attributes available. We did a lot of work on the security layer with TLS, DTLS 1.3, giving a lot of flexibility by separating this out and making it a configurable information piece and untangling the way that we handle security credentials with the server. We are also getting a little bit more, as we grow, we have to figure out how we're doing versioning. So we are getting more clear about that with our lightweight M2M objects. That also goes hand in hand with how IPSO is doing the same thing. with their versioning, as well as we published some additional functionality for how to do firmware updates. Next slide. So Leishan and Wakama are kind of our the Eclipse IoT groups reference open source implementations. So if you guys want to go check it out, it's an easy way to see how this works and get your hands on with what's out there. Next slide. So this is on the IPSO side of things. So here you can see the stack. Where IPSO fits is at the data model layer. I appreciate the 1DM update that we just had. The IPSO group is working with the liaison group there and has contributed all the IPSO objects that we have to the 1DM playground as well. You can go to the next slide. So just real quick, just to understand the IPSO object structure, it's basically an object, an instance, and the object is made up of resources. And we have a format, URI format here, that we can have extensible objects. Objects can be composite objects. If you guys are familiar with this structure, maybe. I can go to the next slide. So here's a number of objects that are made up of resources that are some examples, or they are published and shared with 1DM. And we have object IDs for these objects. If you go to the next slide, you'll see those objects are made up of reusable resources. So this is at the lower sensor level or individual resource level. And so really encouraging the object definitions to use these reusable resources, and we want to grow this where possible. But leveraging a lot of the stuff that we have in 1DM, CNML definitions for these resources. IPSO's point of view is we want to create IPSO IP smart objects that can work with our lightweight M2M management, but we really want to follow whatever the broader industry adoption standards are. I think this 1DM effort is really interesting to us. We don't want to be declaring a particular way to do this. We want to find a broader consensus, and that's kind of our approach to this. Next slide. So we have published some tools from the group. So there's some open source projects and scripts to get your hands on what it means to create and validate an IPSO smart object. So whether you're working in C, JavaScript, or there's an interesting one with BIPSO for BLE characteristics. Here's just for your reference, a way to look at the IPSO registry as well as the scripts to interact and publish your own objects here. So that's all I have. Any questions for us?
So those links on the slides can all be followed, so we can see where BIPSO is done and so on.
Yes.
Okay. Yeah, we have a little time for questions. Okay, I think the fun part will be to see how this all then comes together in the 1DM context. So I'm looking forward to that. But we already have 100 or so IPSO models in the 1DM playground. So much of the work has already been done, which is encouraging.
It's worth pointing out that there are open source tools now that automatically convert between the IPSO XML and SDF and back and forth, and also the OMA models that more or less automate the conversion. Maybe you're going to talk about that in the SDF part, but I thought it'd be a good point to point that out.
Okay,
Yep,
thank
good
you.
point.
So I'm looking for Wouter, who doesn't seem to have himself free from his previous meeting yet. Wouter is sharing a meeting, has been sharing a meeting in the previous hour, so it's sometimes hard to get rid of that. So I think we're going to skip this part here and go right to the W3C segment, which I don't have slides for. Michael, how do you want to do that?
Yes, so if you look in the minutes, you'll see that basically I've linked to the face-to-face slides. I'm just going to share my screen if it's okay. So hopefully you can see now my slides. Let's go full screen here. So now I put a link to this repo into the minutes, and I also linked to some particular slides. So I think that of interest to this group is probably the topics on security, discovery, and probably a life cycle in particular, but also I think profiles and of course thing description are likely to be of interest. Now we've already discussed discovery, I think at great length in previous meetings. So I don't think I want to do a deep dive into that. I think I would like to start, though, by just talking about the Plugfest, which has a summary deck here. So actually, the meeting was 2 weeks long. We had a 1-week Plugfest, and we had a 1-week face-to-face. And the virtual face-to-face was 15 hours of total hours in meetings, which corresponds to a 2.5-day face-to-face, basically. So it's the same length of time as far as total meetings. Now, the Plugfest was also, rather than being a weekend, it took place over an entire week, and we just synchronized, 1 hour a day because of time zone changes. But we also had a virtual VPN set up to share kind of a virtual network. Now, I will say that I think we didn't get well organized enough in advance of the face-to-face, of the Plugfest rather, and so we only got the VPN really functional like on Wednesday of the week. So we didn't accomplish much as I would have hoped, but I think that we did kind of figure out how to do the VPN, and in particular how to do a VPN bridge. So as Michael Koster mentioned before, we had a setup for Raspberry Pi where the Raspberry Pi could then act as a bridge to the VPN network. And then other devices could connect over a Wi-Fi access point or over a wired network and not really know about the VPN at all. They would just connect to a network. The network had a DHCP server and a NAT and so forth, but running in the cloud. And you could also do broadcast packets, so things like, for example, MDNS would work. So we got that working, and I just want to kind of summarize. We got this here down here below. You can see my little Raspberry Pi going through a secondary network interface into a Wi-Fi access point. And it could also have a second upstream interface that it talked to, my local network. And so that was all working. It's not 100% reliable, and so I think we need to, get improvements here. Like I said, I wanted to coordinate with IETF Hackathon because I think something similar would be very useful for the IETF Hackathon. And this is just a summary of the various devices that we had running. So on the VPN, we had, a set of people from different companies, some in Japan, some in Europe, some in Canada, some in various places. And there was a NAT running the cloud that also provided internet access. And then there were various other services that had their own internet, full internet interfaces. The other project we had running was Fraunhofer had an implementation of a directory service, and Fraunhofer has been very active, and I think will, person involved in Fraunhofer is going to be also on the editor's list for the Watt Discovery standard, which is in progress. And so anyways, we had this prototype and we had it running, actually we had both locally behind the NAT and also as a network interface. And one of the things we're kind of looking at is kind of how to federate multiple directory services. But we had TDs for devices getting registered with this. It was a bit of a hack because basically we had a script that just pulled TDs out of the GitHub repo where we had them archived. But I think eventually we need to figure out a way to discover devices and have them register against the directory service. It wasn't quite done yet. So we faked it by pulling things from the GitHub archive. And then the DNS SD was being used by this directory service to provide kind of an introduction service to be able to find the directory in the first place. I think so. Sorry, question?
I think it's also a little bit of an implementation issue, but I think these are
Yeah, so to recap what I talked about for discovery, the idea is to have a two-phase process where there's first an introduction mechanism that finds a directory, and then there's be a standardized directory service, the standardized API. And so DNS SD is just one possible way to do the introduction service. It could be, you could even just give it a URL. That's the most basic introduction mechanism. At any rate, we do have to solve the how to populate the directory service problem. We can register things against the directory, but you still have to, figure out how to do registrations. And so you might need a separate service that is a discoverer that finds devices and then takes on the task of doing the registrations on the behalf of devices that don't do it themselves. So that's still under discussion. And the other project we did was auto population of a node red. So there's another project done by Hitachi, and they had a node red interface. And so what we did is we had a script that could pull information out of the directory and could auto-generate node red nodes, so you could have a use case where someone could just pull up node red, have all the devices magically appear in the dashboard for node red, and then you could drag and drop to build IoT orchestrations. And the idea is the directory could keep track of the various devices and let you search for things you wanted, and then you can automatically generate things. Yeah. There's also some testing tools we looked at. Technical University of Munich has a testing tool where they were reading things, reading TDs, and then generating basically fuzz testing of devices. So you could automatically, poke at devices and make sure they're operational and maybe identify security hazards and so forth. There also is ongoing work about hypermedia. And so basically the problem is that, how do we deal with things like dynamically created resources so there's both things like ongoing actions and events, subscriptions, but there are other kinds of created resources you might want to have. And so the question is, do those resources go into the TD, which will require the TD to constantly be changing? Or do we have some other mechanism to statically declare, like say a URI template that would indicate the format of a dynamic resource, but would not have each individual resource? The problem is that dynamic TDs cause all kinds of complications for directories, because then you have to invalidate caches and things like this. It also is a potential privacy concern because you don't want other people to know about resources they didn't create. And so we are currently, what's that?
I think Wouter needs to mute.
Yeah, if there's a question, please state it clearly and I can answer it otherwise. Yeah, so I pointed at a link earlier.
Put something on screen because I have to do another WebEx in 2 minutes.
What I will say in the earlier section about the Web of Things at the beginning of this meeting, I had a link to the current main issue discussing this whole TDs versus dynamic versus static TDs. And it is a tricky issue, and there's kind of this, what is the boundary between data and metadata? And the idea of dynamic resources is kind of one of those boundary cases. So we have to make a decision about, how static are TDs. There are certainly cases that need to be updated. So one thing we're looking at, for example, is rotating IDs to disable to break tracking algorithms, and that would require some kind of way for directories to notify people that a TD's changed. Okay, so that was the Plug Fest, and we had some interesting work going on, and so we did identify a bunch of issues, and we put those into the testing repo, and we are tracking them. So in particular, some things of relevance here are, we found out that the implementations of JSON path were not really consistent. In particular, the version we were using of JSON path didn't allow recursive searches, which we actually needed for discovery for like listing TDs. So we had to use XPath because it doesn't exist in JSON path, it's that the implementation didn't have it. So there's a problem with not knowing, not having a complete spec for the standard means it's hard to know when an implementation, is completely doing things. We also had an issue with IDs. IDs are optional in TDs, but they're often used as primary keys in databases. And so you have to generate a local key. You can't use the ID field in a TD as your primary key in a database because it may not exist. And so that was another issue that came up. So stuff like this. I think also of relevance, is we need to look at introduction mechanisms that don't have typed links. So there actually are introduction mechanisms that only have a URL. And so we have to know, does that point at a directory or directly at a device? And we have to figure that out kind of dynamically, kind of without having the help of a type. Okay, so that was the Plug Fest. And I think, like I said, other things of relevance are security. There's actually one point here I want to bring up. So I basically brought up some things that were critical for security. So one is we're planning to do, or planning to at least propose having the ability to sign TDs. So we want to be able to have basically a proof section based on JSON-LD proofs that would allow us to maintain the integrity of TDs. And actually, DIDs can also have encrypted IDs that do like a hash of the content, so you can avoid having to change things. This has implications for whether or not TDs can be updated, because if we hash the content of a TD and then we update it, then it changes the ID. And if we sign TDs, there's actually a mechanism for doing proof chaining that we'd have to use there, but it's basically, signing TDs is basically a blockchain type idea. So we do want to have some way though of locking down the content of TDs. The other big topic has been OAuth 2, and we very recently posted a update to TDs. So right now the spec only has the code flow, but it turns out OAuth 2 actually requires, human interaction for granting authorizations and so forth. And so there are cases where you don't want to do that. And there's also an IETF spec for a device flow, which is kind of designed for IoT devices. There's also two OAuth flows that have been deprecated. And so we didn't want to necessarily, we had a discussion whether we included that in the TD spec or not. What's currently on the table is we will not include by default the deprecated flows, implicit and password. We will include core, client, and device. and device being the kind of new one. You can still use the old deprecated flows if you really have to, but you have to include an extension vocabulary to do so. So that's the current, and that's not that released, but it is on the table for being included in probably 1.1 as a backward compatible extension. Let's see. I think that lifecycle was also discussed in the workshop, so I won't dive into that. There was some small updates. Profiles, we're having an ongoing discussion about, how to get interoperability, and basically having a discussion about what a profile should include. And there's also a whole lot of work going on around use cases. And we actually had, I can bring this up actually, it's useful. We had so Michael Galley from Oracle has been working on sorting use cases by priority and who's working on them. And so we had a survey, and he has more updated versions of this. Yeah, so trying to prioritize the various use cases. And so just based on the number of respondents that said it was critical or business relevant, it looks like, smart city manufacturing, energy and smart building come out on top. However, I think there's also things like retail and agriculture that are also pretty, well, okay. Retail is one that's close to the top. And so anyways, this is a sort of discussion we're having. The other thing worth saying is that some of these use cases are vertical, like agriculture, and some are horizontal, like accessibility. Okay, so I think we need to kind of divide these up into horizontal and vertical. And also there's requirements that we need to extract from these use cases. And there's also some things in flight. There's some more agricultural things coming online. There is some stuff on edge computing that is in flight. And there's some smart city related stuff and retail related stuff that's in flight. And then there's these horizontal ones. Okay, so that's use cases. And I think, thing description had some updates as well. And, this is mostly, these slides basically go through. So right now we're basically in cleanup phase, trying to clean up some issues that are ambiguous or confusing or underspecified and get to 1.1. I think one discussion there is if we do, sorry, someone has wind chimes going.
Well, actually, that are cowbells, and
that's my
those
time.
come
Okay.
on when we are at the end of the time allocation for a slot.
Okay, I'm done then. That's what I wanted to stop. So
great. So we have the pointer to that presentation in the notes, I hope.
Well, yes. So I have pointers to the entire repo, and then I have points to some particular ones that I looked at. Yeah, so just follow up and you can see all the details as you wish.
Okay. Thank you. Any quick questions before we go to the next item? Okay, Wouter, can you present your slides?
Yes, I can.
Please do, because my computer is slow for that. Now we see a black.
It's slow. Hey, it has to come through probably the US and then back. So happy to present something that happened in OCF. So I did not use the whole spanning in what OCF means. And that is very, very recently, because it's only something like a week ago that we released a new version called 2.2.0. And what is very new is that we now have an a spec called OCF Cloud API for Cloud Services. What does that do? Well, if you see a little bit to the right, the diagram, if you're talking about IoT, you're talking about things like device-to-device communication. That was already there from the beginning. Then we started to talk about bridging. So basically that you have other devices, other ecosystems where you can talk to. So we have a complete bridging architecture. Then, of course, you have the use cases that you have a smartphone IP connected and you want to talk to your home. So you want to do something with remote access through a cloud service. So then cloud technology is born. And then certainly you have another issue that if you have a device connected to a specific cloud and you have another device that is connected to another cloud, that you want to aggregate them from user perspective. So that's where the cloud-to-cloud stuff comes into. The basic thing, and I think it's also a very nice integration layer that can be used going forward, but that's something for the future. Basically, if you have an account in the cloud by means of an OAuth server, so you have a user account there, and you have another cloud with another user ID, we use standard technologies to do that matching up. And then, of course, all the OCF devices, device listings, you need to communicate that between those clouds so that you can synchronize the view on both sides with devices and clients you have. So that was a decent amount of work to get done, and everything is there. Open source is there as well. So I think this is a huge step forward for cloud integrations as well. So it's really making things easier for ourselves. To underpin all this work, and that's why most of this stuff is hard to do, we have code running on the device in IETF. Probably most of the people know that already, that that's code base is available, open source, Apache 2 license, so what's not to like. But the cloud stuff is, well, it doesn't have to be targeted to a small device, a small CPU, and crunching the size to fit on small CPUs. Cloud stuff is really, really different. So you really want to make it scalable, having that done in different technologies. So that's why we have a different code base there, and it's based on Go, and it's well, we call it Go OCF, and there is one repo that has quite a lot of Docker containers already completely configured, and there is also an experimental instance of the cloud and cloud-to-cloud technology there already. So it's already available that you can play with it. So this, well, together with the spec works that we did and getting this done, that was the major work that we did in the last year. There's a directional change that is nice to mention is that previously we, well, something like a year ago, 2 years ago, we always talked about OCF as a complete complete stack, full stack, including data models. But we got some indications by other vendors, but also from other organizations that what we are doing as a framework is pretty nice. So what we did as a directional change is that you can also use what we call now the OCF core framework as a complete stack, and you can just build your own app, your own protocols on top of it. And what this gives is then that you can use a standardized framework, and that standardized framework itself is completely secure. It secures all the endpoints of your application. And that's hopefully a step forward to the market, because there are quite a lot of IP projects that, well, don't want to use a standard, but needs to be secure. And we try to enable this kind of work by having this OCF core framework. We would like to enable those kind of possibilities for non-standardized ecosystems or ecosystems that want to move to IP. It's what you want to do with it, what makes sense. And this is all across all the models, the network configurations that I showed in the first slide. So you can transport your model then on top of the framework on the proximal network, but also through the cloud and cloud-to-cloud technologies. That all works. I think this is also a step forward for the whole industry to get more adoption for IoT. The other thing that we are looking at is the security. We already have. Can I have 2 more minutes? So one of the things that we think is good to have is everybody's looking at what is the legislation government's doing about security. So we already identified 5 different documents that have security requirements, and we are ranking ourselves against those requirements. And well, luckily, well, it's not luck, of course. We are trying to match as much of them. The red ones that we think we can meet, but we did not meet them yet. And of course, there are requirements in those documents that are not applicable because they are not about a standard or an ecosystem. They are about vendor kind of technologies. So I think this is also a step forward in recognizing that we are looking at what the legislation organizational-wise is doing, that we are trying to meet their challenges that I see. And the last slide. So one of the things that we are doing quite a bit is cooperation with other standards. So recently, IP Bliss has been announced. That is a cooperation between BACnet, thread organization, ZigBee, and KNX and OCF to move forward in building automation that everybody wants to use IP. So that's a huge thing because KNX and BACnet are known to have not yet to be there on IP. So they are saying that they want to move to IP is a big thing. That OCF is there is well, a minor thing because we are already IP based. So from that perspective, as a directional setting, IP Bliss will do good for IoT as a whole, that everything will move to IP. And of course, all the security stuff that I mentioned in the previous slide would come into play. Another thing that we are working heavily on is 1DM. That's a cooperation between, what's also started out as a liaison between multiple parties, but it's now public. And one of the things that we are trying to do is making sure that data models as a whole are being aligned across, as many as possible industries. So please take a look at that as well. And that fits into that we have something like the core framework, so that, well, whatever models comes out of this work, you can just transport it over the OCF core framework. And even if you have a different model that's not being accepted, then you can also transport it over the core framework. So, thanks for those additional minutes, because that was my last slide. Any questions?
I would have one, Matthias, this IP Bliss, is this like a continuation of Fairhair, or how do these two relate?
No, it's not a continuation of Fairhair. Fairhair was a separate organization, but it was very IPR friendly because IPR did not exist there. IP Bliss is really a liaison between those organizations, and it's we are saying that it's marketing, but of course it will do technical things going forward. It's mainly getting everybody on the network and making sure that the coexistence of those different application protocols will exist, but it's not coexistent. It is then leverage each other so that you can use OCF together with BACnet, together with KNX, what the best way of doing is. So one thing that we did in 1DM is looking at the different organizations and where they were good at. And basically in IP Bliss, we will do probably the same thing in what is good and what is where an organization is good in, and use and try to push that and leverage that as much as possible. But it's definitely not a continuation of Fairhair. But yeah, the principles that were written down in Fairhair probably would apply.
Mm-hmm. Okay, thanks.
Okay, let's look at the schedule. We have pretty much squeezed Michael's presentation about IOTSF out of the agenda. Michael, you maybe just want to say one or two sentences why my Chrome is starting to share things again?
So I did do a presentation at the IETF Directorate, which is recorded, and they are, IOTSF is doing a series of training courses, which I'm involved in creating, and those will get announced probably next week. And they also have some work on supply chain security, but it is still very, very young.
Thank you. And quick question for Michael. We can link to the IoT Directorate notes in our notes. So if you want to learn more, you can look there. So sorry for squeezing you out, Michael, but
I actually screwed up what hour it started. Came an hour late.
Yeah. I think we can have a more detailed discussion of IOTSF next time we meet. So thank you for that. And let me quickly point to the ASDF BOF that is happening at the IETF 108. And I think we have talked about 1DM. And the interesting thing from an IETF point of view is that there have been a few people pointing to 1DM repeatedly over time, but because 1DM tried to avoid being that 15th standard and really wanted to operate as a liaison organization, they haven't done the press releases and all this stuff that competing organizations usually do. So they were essentially running in stealth mode for a year, and now we have a little problem because a lot of people in the IETF don't know about that, at least those people who haven't been to research group meetings where we have talked about 1DM. So 3 days ago, 1DM finally decided to actually do the coming out, and there is now a website, 1dm.org, that has a lot of information. And I'm saying this because 1DM essentially has done three things that are of note. One is the agreement on a legal model that Michael talked about, that everything is done based on BSD3 clause and so on. We are not doing this old IPR heavy way of doing things that has already killed other organizations. The second thing is we have a common specification format, and this is really what the BOF will be about. And the third thing is we have started to collect a couple hundred contributed data models. Right now there are 4 SDOs in there. I hope there will be other SDOs soon. So we are trying to show that the mechanisms actually work. 1DM spent a lot of time about pressure testing the specification, which is really just trying to convert data models into the common format and see whether we can express what we want. Now, SDF has been released as a 1.0, but it's not yet complete. It doesn't have all the features. It doesn't have all the normative specificity that we want from a standard and so on. So the question is, who actually does the work of leading SDF 1.0 forward to a standard? And that's actually something that 1DM thinks could be done in the IETF. So the IETF would define the format, but would not really be working a lot on doing data models. I mean, I don't want to completely exclude that this ever happens, that the IETF thinks it's useful to have data models defined in SDF, in particular when it comes to network management, that might actually happen. But IETF would then be one of the blue boxes down there, blue-green boxes, ecosystem 1, ecosystem 2, that are contributing to the area where 1DM really is about harmonizing the data models. So this is the idea, and the BOF is happening Tuesday in 12 days. It's called ASDF, Semantic Definition Format. It's a non-working group forming BOF, because some people thought we need to have this dialogue about what 1DM and SDF and all the other SDOs in this space are about, and whether we even can find a way to work together, a common process that is not stuck in some IPR issues. And I think we are in a very good position right now due to the work that 1DM did, but we have to complete that and get people talking to each other. So this is the objective of the BOF, and I would hope that we can get people from all kinds of organizations coming in and explain how they are trying to work together using this semantic definition format, and how IETF could do its part in completing the specification. Any questions about that? Okay, in which case, we go on to Xavier.
Thank you, Karsten. Yeah. So, hi. I'd like to present our progress on the draft IoT Edge Computing Challenges and Functions on behalf of my co-authors. So, could you please go to the next slide? Thank you. So I will not go over the history of the draft. It's just here for reference and to show that basically this work started 2 years ago, and it evolved quite a lot. So today we are looking at revisions 4 and 5, and 5 is proposed for adoption. So we addressed comments, we completed sections. So we will look at this in the next slides. Thank you. So in the first part of the update, so we addressed comments mostly from Thomas on the list. There were improvements to section 3, IoT challenges leading towards the adoption of edge computing. So for example, resilience to intermittent services now include enabling a cloud service to access a device currently asleep. And hiding traffic patterns from devices is another privacy application of IoT edge computing. So there were also improvements to the document structure. So we removed the appendix. It was moved to another draft just for reference. And we moved also a section, an overview section later in the draft, just to improve the flow. And we made editorial fixes as well. And also Ari provided some comments, and we made a revision 5 prior to the call for adoption. So next slide, please. Thank you. The other part of the update was planned since the last IETF meeting. So we completed sections 4 and 5. So we added an example of distributed IoT edge computing next to the general model. And the next one is a bit major one. We added research challenges associated with each function that we identified. And then we filled the security section with the positive and negative impacts of edge computing. So I think altogether this kind of completes the draft itself. Many editorial changes were also made to improve clarity and flow. And in the next slide, we'll, since there is, thank you, since there is a call for adoption for this draft, I just would like to give a quick overview of what is in the document so that you can see if you are interested in looking at it and waiting in the mailing list. So after the introduction, we have a background section covering IoT, cloud computing, edge computing, and with a few use cases. And the core is really of the document, that's really section 3 and 4. So in section 3, we cover IoT challenges leading towards the adoption of edge computing. We have challenges that are time sensitivity, uplink cost, resilience to intermittent connectivity, and privacy and security. So those are based on earlier work made in the T2TRG research group before we started the draft. I think Eve and Dirk were involved in this. Then section 4 describes IoT edge computing functions. So it starts with an overview of the current use of IoT edge computing based on a review of current standard research and industry projects, which is now in the separate draft. And also it has a very simple general model that we use basically to introduce a list of functions or components. And those are organized in the 3 groups. OEM, functional, and application. So this classification is for, really for clarity only. Different systems or system designs may couple those functions in various ways. So here we are not prescribing one particular system design, but really trying to cover the different types of functions that you may find in IoT edge computing systems. There is also a short discussion on simulation and emulation environments and security considerations. So in conclusion, the last slide, thank you. We believe, at least the co-authors believe, that the draft is now complete. So in conclusion, it really introduces IoT edge computing, and it describes why we need it. So that's the first part. And also it describes a simple architecture model. It lists major functions and associated research challenges. So as a conclusion, we think it provides context for future work in this area in IRTF to be used as a reference, and also to provide some context on how future work basically relates to other parts. Right, so a good review which was made since last IETF helped fixing some issues with the flow and reduce the size of the draft. And so now we propose a draft for adoption. And if you are interested, please review and provide some feedback on the list. So, thank you. And Karsten, back to you.
Thank you, Xavier. So are there any questions about what Xavier presented? So we have the adoption call running, so you can respond to the research group adoption call. When is it running out? Does anyone remember?
I think we got 2 weeks started on Monday, so we kind of have to go.
I have a question at this point.
Good.
Hi, Xavier.
Hi, how are you?
I'm doing good. There was the last email about the call for adoption of this draft, and it was mentioned that in the end, it's also interested to hear about further reviews. So I wanted to know if there are still places for open comments in these documents, or only minor editorial changes.
Oh, thank you for the question. I mean, I think that here the call is for adoption by the research group, which means it will change in the future. That is basically, instead of being driven by the authors, it becomes driven by the group. And as a personal, input on that, I think, for example, the research challenges that are listed, for example, that's a very good part where actually we need input from people here. Like, for example, we heard today some discussion. There was a discussion about discovery, and I think that's also related to edge computing. So there is a part of on this in the research challenges. So anyway, so that's my take on it. Maybe the chairs will have additional.
So I think what Xavier is trying to say is that, yes, please, if you have interest in reviewing it, please review it. That would be very helpful.
Actually,
it's not fixed by any stretch of the imagination. You know, it's like just being affiliated now officially with the working group.
Yeah, I'm still yet to go through the full version because I recently was working on the research on edge computing myself. So I may have some points to as a feedback or as a comment, or maybe some new points to add. So was just wondering if this is the end of the draft, or further revisions are on the page. So okay, I'll have a look, and then if there's anything, then I can maybe propose on the mailing list itself, or it would be a new version.
No, I think please go on the mailing list and indicate if you would like the research group to continue this work. Basically, that's what I believe that's what the call is about also. So definitely your input will be more than welcome. Thank you.
Yeah, sure. Thanks.
Can you put a link to that list or something in the minutes so we can find it more easily afterwards?
Yes, a link to which part? Sorry, I didn't get.
Well, can you just give the name of the list in the minutes explicitly so we can find it, so we can, and also maybe a link to the draft so we could also find it more easily.
Okay, so a link to the draft, and you mean a link to the call for adoption email?
Yeah, so if there's a mailing list at our call, and so we can follow up. I will say I'm going to be reviewing and putting in my support here. In fact, I just wrote for Watt edge computing use case, and I want to align that with this.
Okay, thank you. Yeah, definitely. Please provide feedback and input on this. That we'll be very happy to integrate and to grow the document, because I think the co-authors really provided what we could, but I think now that's a time where we need more input.
Yeah, there's also an activity going on in web and networks around edge computing right now in W3C that I think is also maybe relevant. I can point you some stuff there if you're interested.
Thank you.
So just to throw up a few more things that people might want to think about. The questions that came up in previous discussions of this focused on two questions that I think we will continue discussing when this becomes a research group document, and we can start thinking more about it now. One question was whether edge computing actually is a sharp technical term, or is it actually just a marketing term? And there are maybe one or more concepts behind that, trying to get out that would apply beyond where the marketing term edge computing works. So I don't want an answer right now. I just want to throw up the question. So I think that's one of the things that we try to do in a research group, really sharpen the terminology and understand what the terminology implies and does not imply, and how it can be useful on a technical level. And the other thing was that De Kutcher had a nice outrageous opinion talk a while ago where he came up with a number of requirements that really must be met for edge computing to actually happen, to be widely deployed. And I think that's also something that we might want to pick up and discuss in more detail. What are the success factors here? And of course, the success factors are not all technical. Some of them are actually very much commercial. But I think it's a good idea to think about those as well, so we don't have a nicely structured item of work that is not being used anywhere. So these were these would be the two things where I would like to see more input and reviews and in the discussion on the mailing list. Any other comments? Thank you. In which case, we are done with the agenda. As I said, we are probably going to have a summary meeting before or with IETF 109 again. And in the meantime, there is the mailing list that was just posted to the chat. And we also will have the regular wishing calls on one of our subjects. And that doesn't mean that we cannot have regular calls on other subjects as well. It's just that Rishi seems to have a lot of energy at the moment. So any last words from somebody else? Thank you. So we made it on time, and have a nice IETF 108.
Thanks. Bye-bye.
Bye-bye.
Thanks. Bye.
Everyone.
Bye. Thank you.
Bye.